Oh
I'm
man,
so sorry.
that's such good timing. That is the best. Oh, here you go. You get a repeat performance of Pamela's dog Malachi just jumping up right in front. You know
You're
what? Let's
fantastic.
just instead of
There
doing
we
an
go.
episode of Astronomy Cast, why don't we just have Malachi just ham it up to the camera for an hour?
It's- he just knows that this chair is big enough for both of us, and even though I pushed the ottoman away to discourage this behavior,
Yeah.
he's currently lying with his back end on the ottoman. There's a gap of about a foot, and his front end is on me.
Yeah. Yeah, it is hopeless. I mean, it's the same situation. Like if you are gonna attempt to just live a normal life with the needs of a dog, you are sadly mistaken. Your needs are subservient to whatever the dog wants. Yeah.
Yeah. And
Yeah.
and each of the dogs has a different surface that when I'm on it, I belong to them. So,
Yeah.
like, if I'm in my upstairs chair, I belong to Stella. If I'm in
Yeah.
the living room chair, I belong to Eddie. And if I'm in this chair, I apparently belong to Malachi.
Yes. Yeah.
This is my life now.
Yeah. 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 And times three. So you like I feel like a person could realize that there's a certain situation brewing and then stop at one, but no, you tripled down on this one. So yeah, but you know what? It's fine. It only improves the show, makes it better. More dog, more better. I believe is the way this works. Like it's the math woven in to the very fine structure of the universe. More dog,
Yes,
more better.
exactly.
How's it going, Pamela? Apart from the doggening.
Oh, I am in full on prep for our Hangout-a-thon.
Mhm.
And we have an amazing gift that will be going to the highest donor if they exceed a certain amount. There's a tradition of passing things forward. And Guido, a number of years ago, was the winner of an amazing palisite meteorite encased in acrylic. And he's putting it forward that if someone tops the donation that he gave back in 2015, they will get to take home this palisite this year. So I'm
Nice.
super excited about that. It was over $1,000. I don't remember if it was over
Wow.
$3,000. It was that order, and it's just awesome.
That's stunning.
Yeah, we're pulling everything together. You now have the schedule, and I'm waiting to see what you are interested in being part
Mm.
of. And
I didn't realize I had to take action. Okay, I'll take a look.
I sent you a myriad of options.
That's
Um, and last night we picked out where in our Minecraft server we're resetting spawn to build. We're going to build a rocket park in Minecraft.
nice.
So yeah, everything is slowly coming together, and it's kind of awesome.
That is super cool. Man, the work that goes into your Minecraft, like the solar was it last year was the
Yeah.
solar system?
Yeah, and that's still there. People can still
Yeah.
go. And I don't think Saturn and Jupiter are ever going to be completed. Dog, dog.
Your
Sorry.
your camera just shifted. What's
Yeah,
that
there
about?
there was a
How did
dog
that
quake.
happen?
Dog quake. Yeah. Yeah, okay. There we go.
Um,
Hi.
uh, you're back. So for the rocket park,
Yeah.
obviously, I mean, that means that someone's got to build like a Saturn V, a space
Yeah.
shuttle, a Starship, an
And
Enterprise.
and
What do we
hopefully
got?
it's going to be a bunch of different people. Um because otherwise it's never going to get completed. And this is
Mhm.
taking inspiration. Have you played Animal Crossing New Horizons at all?
No.
Okay. You are like one of 12 adults that did not fall prey to this.
Yes.
So a whole bunch of us got sucked into Animal Crossing. And one of the things they have is there's a museum and you can dig up fossils on your island
Mm.
and get fossils when you visit other islands. And the goal is to collect an entire suite of these fossils. And in the museum, it creates a tree of life that allows you to see how one dinosaur descended from another dinosaur to eventually get us to the age of the massive mammals and even to humanity. And we decided we're going to replicate that idea of the tree of life, except for the tree of rockets.
Oh, that's awesome.
And so like solid rockets all descend from Chinese fireworks. And
Mhm.
and so I'm just really looking forward to uh, seeing what everyone creates. And I'm going to work on building the welcoming center all day tomorrow. I'll probably stream that. And I'm going to ask some of my friends who are way better at Minecraft than I am. I'm a good architect. I'm a
Yep.
lousy chemist. So I'm going to ask them to put together a pyrotechnics display that can be launched off the roof of the Welcome Center.
Wow.
Yep.
Crazy. That's awesome. And then, of course, you've got lots of interviews planned and all kinds of games and all kinds of fun stuff for the Hangout-a-thon. So I am I'm looking forward to being a part of it.
And
However, I just need to schedule it, or I'll be left with whatever's left. 4 in the morning, Fraser is not
No,
entertaining.
we're not
So,
going to do
yeah.
that to you. We like you too much. And for those of you who are new to this idea of this hangout-a-thon, the goal is to make up the difference between what we bring in on Patreon and what we actually need to pay all the folks behind the scenes. Like Allie's behind the scenes producing today. Normally that would be Beth. We have Nancy, who is cat wrangler extraordinaire. We have Rich, who does our audio. Allie does our video. We have servers that we pay for. And keeping everything going costs money. And the difference between what we bring in on Patreon and what we actually need to just keep things going is $40,000. And if we want to do things right, like everyone gets the number of hours that they wish they had so that they weren't taking every possible shortcut, it turns out that budget we need about $200,000.
Right. Right.
So we are looking for corporate sponsors, individual donations. Patreon and Kindful are the two big ways
Yeah.
that people can donate. Check out cosmoquest.org. Follow the big image to Hangout-a-thon, countdown to flight, and be part of allowing us to just do more, bring back the science, and
Yep.
keep going.
Fantastic. So if communicating science is important to you, if just the work that we do through Astronomy Cast, CosmoQuest, Daily Space, all of that, of getting the word out about space and
Yeah,
astronomy and covering these kinds of events, encouraging scientific interest is important to you, then at very least come and hang out in the Hangout-a-thon. And if you can, of course, contribute only if you can. Not
yeah,
Don't
yeah.
feel
And
guilty
there's
if you
door
can't.
prizes that you can get just for showing up and collecting channel points. So
Yep.
just
Very
come,
cool.
come have fun.
Awesome. All right. When the last few saw our heroes, they made episodes of Astronomy Cast, so
It's
perhaps
true.
we should do that.
It's true.
Okay. All right. I'm gonna bring up my recording device and begin the recording.
Okay, and I'm going to bring up my notes because there are humans whose names I will get wrong if I
Badigan.
don't.
Badigan.
It's him I'm good with. It's the person
Okay.
who works with Scott Shepard, who's Trujillo.
Oh.
Charles Trujillo, I think is the name. But this is why I'm pulling up my notes.
Mm.
Why did it get rid of my notes while I was... My dog closed the page I had open. Dear dog. Dear dog.
That is funny.
So it's
That's too
Constantine
far.
Badigan
Badigan.
and Chad, not Charles. Chad
Yeah.
Trujillo is the other one. Okay.
Hio. Chad Trujillo, I would guess.
Trujillo.
That would be my guess.
How were you saying it?
Hio. Hio.
Trujillo?
Hio. You don't say the LLLs when it's two L's in a Spanish sounding name.
Trujillo?
Trujillo.
Trujillo. Okay.
But that's just my guess. I mean, he may go by Chad Trujillo, but I
Well,
don't know.
I was doing it like the L in llama, so This is what happens when you read more than you talk out loud, humans. This is what happens.
At least I can now pronounce Chinese names really well.
Yes, you can. It's kind of awesome. How many
Yeah.
years have you been working in Chinese?
Maybe 18 months.
Okay,
Yeah.
yeah.
Are you ready?
I am.
Okay. Tell me when you press record, and then it didn't work, and then you had to press record again.
Allie has it under control. She's
Oh,
done the
okay.
thing.
Oh, wow.
Yeah,
Okay. Well,
yeah.
then I take back my
All I have to do is sit here and
perfect
be
and
scientific
and fend off dogs.
and mispronounce people's names because unfortunately that's what I do and I hate it, but it's what I do.
All right. Here we go. Astronomy Cast, episode 615, The Search for Planet 9. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser, Cain, publisher of Universe Today. With me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I am doing well. There is so much going on right now. The day after we record this, Saturday, it's International Observe the Moon Night. Next weekend is Hangout-a-thon. Fall is here, Halloween. For those of you watching the video, Felix the Dragon is hanging out behind me celebrating October. Life is good. Life is good.
So I want to shamelessly self-promote the sun today, which is, of course, we've left the solar minimum. We are now driving towards the solar maximum, and that means auroras. And so we had an
Oh,
incredible aurora display that hit a big chunk of the Earth in the last couple of days
yeah.
from when we're recording this. I was really lucky. I had surprisingly clear skies and could see auroras off on the horizon.
Oh,
Um, Beautiful display. I was able to catch it on my phone, of all things.
dang.
But people, as like in New York State, people in sort of some of the middle latitudes were able to see it as well. So uh now is the time, if you are interested, if you've never seen an aurora and you live, I would say, above the 35th
Yeah.
parallel, then you have a good-ish chance a couple of times a year of being able to see an aurora, but you've got to be prepared. So get yourself acquainted with NOAA's Aurora Alert. Find an app that you can put on your phone that'll tell you when there's aurora activity in your area. Have a plan for a place you can go where you have dark skies and a view to the correct, uh, towards the correct pole. In our case, we want to be able to have a nice dark view to the north. If you live in the southern hemisphere, you want a nice dark view to the south. Plan this all out, and then when the aurora activity is peaking, and you're not going to feel like doing this, you're going to feel like it's cold and you don't want to go out. Go out. If it's
This
clear
this is
skies, go see it.
this
And
is this is the one time you don't want a hammock. And any of you who've been watching for a while know I am a strong proponent of hammocks.
yeah,
But there are these really nice infinity chairs, zero gravity chairs, whatever you want to call them. They're ones that let you lean back, but not all the way. Uh, we will link to them in the show notes. Get yourself something that is extraordinarily comfortable,
yeah,
and then get insulation for beneath you
yes,
and above you. Prepare to mummify yourself.
yeah.
There are these amazing camping wraps that are like sleeping bags you can walk in. This is what you want. This time of year and March are the two times of year that you want to go out and see this stuff. It's the best alignments.
Yeah, and you don't, and this is the, like, with a meteor shower, say the Perseid meteor shower, you know that you're going to be seeing meteors every minute or so, and so you don't have to wait very long. But with auroras, you could go out and see nothing, and then you could go out again and see nothing, and then you could go out again and see like just a faint hint on the horizon. But if you wait 2 hours, 3 hours,
Yeah.
you could get one of these fantastic aurora displays where the auroras are just raining down on top of you. The sky is dancing
Yeah.
from horizon to horizon, and it's an absolutely magical experience that you'll never forget, but you won't see it unless you get out in it. And so it takes some preparation, and it takes some patience, and it takes a certain amount of just of just being willing to endure while you wait for the chance. But I gotta say, when they happen, they're like nothing else you've ever seen. So if that's on your bucket list, then now is the time to start preparing an action plan to take advantage of it. All right, let's get into to the show. So after Pluto lost its planethood, we were down to 8 planets, but there's growing evidence of another world or worlds out beyond the orbit of Pluto. Is Planet 9 out there, and how will we find it? Could there even be a Planet 10? And we will find out shortly. But first, let's have a break. And we're back. All right, so I mean, I guess we all know this. We talked about planet Pluto and its loss of planethood just a couple of episodes ago, a refresh. So now Planet 9. And we have done an episode on Planet 9, but give sort of the quick version of what Planet 9 is.
Planet Nine is a world that has been most publicized by the team of Michael Brown and Konstantin Budigan, who looked at the orbits of a suite of Kuiper Belt objects that had super weird orbits, and they ran a bunch of models to see if there was a way to explain these orbits, and realized that one of the best ways to explain them was with initially they calculated it out to be a 10 Earth mass, either Earth-like world or Neptune-like world that is hundreds of astronomical units, probably 200 to 300 astronomical units, or times the distance of the Earth to the sun away, and is just out there influencing all these smaller bodies to enter these weirdo orbits. Now, they weren't the only ones that came up with this idea, and people often forget that even earlier, Scott Shepard and Chad DeHulo had also come up with the idea of looking at a different set of screwed up orbits of Kuiper Belt objects. They also postulated there might be something else out there, similar mass. They were using different objects, so they got slightly different orbits. There's some controversy there that I suspect we're going to get to, but
Mention that of course their discovery was met with incredible lack of skepticism, right? Their suggestion that these worlds were out there, everyone just fell in line
no.
and got to work searching for them. No.
Well, they did get to work searching for them. I will give them that. This is one of those things where I think pretty much everyone is like, I wouldn't bet money on them being right, but I would bet telescope time, because if
Yes.
this is right, it is so, so cool. And currently there are teams using the Subaru telescope in Hawaii to frantically, well, frantically is the wrong word. They'd have more telescope time if it was frantic.
Desperately
To
scurrying
desperately,
around,
there's,
twirling dials, switching knobs.
well,
Yeah.
there's a whole lot of not enough telescope time, but a lot of emotional energy in what telescope time there is
Yeah.
to going out and searching the regions of the sky that haven't been eliminated yet as the possible home for a massive object.
So then, I mean, and like, I'm just trying to sort of think about like what that evidence looks like and how sure are they that this object is out there?
So when they first did, when Michael Brown and Konstantin Budigan first did their calculations, they came up with a 1 in 10,000 chance that what they were seeing were completely random alignments. But over the years, as more data has been acquired and as more effort has been taken to remove from the calculations any worlds that are being perturbed by Neptune, it has dropped to more like a 1 in 250 chance that this is just random. And 1 in 250 isn't like that unusual, but we want it to be there. Not gonna lie, we want the world to be there. Yeah.
Sedna. There's a lot of these really big objects out there in the outer solar system. It seems inevitable that something bigger is lurking out there, either something that formed in place or something that was kicked out from the inner solar system through all the various interactions. I mean, we know that Jupiter hurled a lot of material out into the solar system, and so it's not surprising that something is out there. Um, 1 in 250. I like those odds. And
Yeah.
so they updated. I know that Brown and Badigan updated their research fairly recently, just a couple of months ago, with a firmer estimate of not only what the odds are, but even where to look.
Yes. And it turns out the object is probably both closer, brighter, smaller than originally thought. And if it's out there, it was earlier on calculated that it was probably somewhere in the vicinity of the Orion constellation, but like in this massive swath of sky. And the possible area of sky has now been narrowed down. Unfortunately, this is an area of the sky that's extraordinarily rich in background objects, in background nebulosity, in all sorts of things that makes it super hard to find a not entirely bright, very slow moving object. And one of the things that Mike Brown has said that I deeply appreciate is we've probably already imaged this object if it's out there. We just don't know it because of the rate at which it's moving. It's just not going, hey, I'm a moving object. It's just hanging out there pretending to be a star.
So one quick note: people are saying that when the camera shifts to you full screen, they can't hear me.
Okay. Okay. Allie knows how to fix it. And we are recording all of the audio on both sides.
Yes, yeah. So it'll definitely show up in the podcast edition.
And we'll get the audio to Rich, and he should be able to fix it for the video edition. And this gives me a chance to sniffle because it is allergy season. So Fraser, it just says Fraser, and then you mute the video. So it's under network. And then, okay. And you added me to his? It would be the Brio audio is the one that's working. We're listening to the producer in our ears.
Yeah. So sorry, I guess people can't tell that we're listening to the producer right now. We're just standing here, and you're like talking to nobody. So, and apologies to Rich. This is going to require
Surgery.
some surgery on the audio. And
It's
Nancy
actually
makes some
not that bad.
calculations. No, you just cut out big giant
Yeah.
swaths, but also it changes the timing for the next ad break, which I'm assuming we probably should go to in a second anyway.
Yeah.
Okay. Okay. All right.
Awesome.
All right. We're going to talk about this more in a second, but it's time for a break. And we're back. So, I mean, you described a bunch of objects of varying sizes and at varying distances. It seemed pretty vague. So let's talk about the hunt. And you mentioned that it's almost certain that there's a photograph out there right now that contains an image of Planet 9 in it.
Yes.
And yet nobody has realized that that's what they've got their hands on. Why is that? Why wouldn't they know that they've got an image of Planet 9?
Well, one night's observations may not be enough, especially if you don't have perfect seeing, to notice this object moving across the sky. So it may end up that if you have several hours of observations that you happen to combine, that it might look a little bit elongated, maybe, probably not. And it's that slow motion and the fact that researchers generally will only get a few nights consecutively to go searching that causes these issues. You have to have nights that are much more spread out to successfully go looking for these kinds of things.
Right, right. So I mean, the discovery of asteroids is all about time domain astronomy, that you
Yeah,
have to take pictures night after night after night and then flick between the images that you're looking at to look for the object that is moving bit by bit
yeah,
through the field of view. And in many cases, yeah, an astronomer is absolutely taking an image of some field, some long duration image, so they can look at a galaxy or study a supernova or whatever, but they're not coming back a month later and doing it again and then comparing the two. Like their telescope time is done and the telescope's moved
yeah.
on. And so they're not set up to search for these kinds of objects. And you do need a very powerful telescope, like the all sky scanning telescopes, like a lot of these automated telescopes are just not going to be able to pick up an object this faint. So let's talk about the wonderful observatory that will probably be able to find it.
So unfortunately, COVID has delayed this telescope like so many things. The Large Synoptic Survey Telescope, which has been renamed the Vera Rubin Observatory, and it's now doing a LSST is the name of the survey they're doing, and I no longer know what the acronym stands for,
Right.
but I know the telescope is awesome and nearing completion. We just need to be able to finish it. And once it's open, once it has first light, once it's able to hit its full cadence, it's going to be imaging the entire visible sky every few nights. And while it's a southern hemisphere telescope, it's not so far south that it can't see the parts of the sky that we're interested in. And that means that it's going to have the kind of cadence where it's going to be able to find every fairly large Pluto and bigger object in Neptune and another 10 AU or so out objects, and bigger objects to greater and greater distances, and shinier objects to greater and greater
Hmm.
distances. And we're finally going to know what's out there and be able to either find this object or prove which of the alternative hypotheses turned out to be the real reason that there isn't actually another planet or two out there.
We had a bit of a sneak preview of this. There's a recent mission or recent observation called the Dark Energy Survey
Yeah,
camera, and they're looking for evidence of
dark
dark
energy.
energy and trying to sense dark energy's presence on the universe. They're looking for supernova, things that
Yeah,
change. And while they were at it, it also happens to be a terrific asteroid Kuiper Belt object
yeah.
hunter. And so over 6 years of observations, they were able to observe 1,000 Kuiper Belt objects, half of which were brand new, never seen before. And so just as these missions come together and as they do longer observations, more and more of these objects turn up. And when you do turn one of the most powerful telescopes in the world on these targets, then you get a tremendous amount of detail. This is sort of a rabbit hole, totally unrelated. But did you see this incredible set of images of the 42
Yeah.
asteroids from the European Southern Observatory?
Yeah, it was just like they used some of the best telescopes in the world to look at space rocks and got some kind of amazing
Yeah,
results. And the one that kind of made me sad is there's a dog bone shaped asteroid that looks super
Cleopatra.
like, yeah, it looks super like a dog bone in the Arecibo radar data. And it looks much less impressive directly imaged. And I was like, I want my dog bone asteroid. So it's
Yeah,
it's it's like the face on Mars. Sometimes too much resolution does you in with
right.
pareidolia.
And so if someone is able to find the location of Planet Nine,
Yeah.
then the European Southern Observatory's very large telescope will turn on it and deliver the best possible images that we have until James Webb flies in a couple of months.
Yeah.
So so let's talk about then Planet 10.
Yeah. So work that Kate Volk and others did. She was doing a lot of this as an early career researcher. looked at the distribution of Kuiper Belt objects, the fact that there's like a cliff in their distribution out somewhere around 60 AU roughly, and did some modeling and realized there could be Mars-sized objects out there influencing these orbits, creating resonances. And what's amazing, to me at least, is with our current definition of planet, if you stick a Mars-sized object out into the Kuiper Belt, there's a good chance it won't be able to clear its orbit and won't
Mhm.
be technically a planet. And so this gets into all sorts of neat semantic arguments of what do you do when you find a new Mars hanging out, unable to clear its orbit? And hopefully a discovery like that will be made and will reopen these debates.
All right, well, let's have a mini version of that debate in a second, but it's time for another break. And we're back. So I guess what you're saying here is like if we find an object that is the size of Mars, so bigger than Pluto,
Mm-hmm.
and yet it hasn't cleared out its orbit, yet
Yep.
it's spherical,
Yep.
orbits the sun,
Yep.
is it a planet?
Technically, no.
Technically, no. Even if it's the size of Neptune and still hasn't cleared out its
Well,
orbit. I mean,
and that's
it's
where
a
it gets
it's a
squirrely.
big space out there. Yeah.
So Neptune would probably count as a planet because it's substantially larger than everything around it. But something the size of Mars isn't orders of magnitude bigger than Pluto.
Yeah.
And it's that difference where Neptune hasn't cleared its orbit. Its orbit contains Pluto, for crying out loud.
Sure, but it
And
dominates its orbit.
it dominates its orbit. So Neptune counts as a planet. Jupiter shares its orbit with the Trojans that Lucy's hopefully going to launch and go explore. And so we have these exceptions where it's like, well, that counts as sufficiently large enough.
Well,
And a
the,
Mars-sized
so
object probably wouldn't and would
yeah,
reopen this debate.
people would definitely like if there's an object bigger than Mars, people
Yeah,
will definitely call it a planet.
that's my hope. I just want a geology-based definition, something that says if it's capable of having differentiated crust, volcanism, cryovolcanism, active
But that
tectonics, that is a planet or a moon, and we call them both worlds. I want the word world to come back.
sure. I just do not care. Like no part of me cares. Like
All
I
right.
can't I, yeah, I have zero F's to give on this one. The like we're never going back. Like I think that's the thing that's really important to understand. Like as soon as you like, yeah, we had 9 planets because that's what you grew up with.
Yeah.
But not if you lived in the 1900s. Then you grew up with Ceres and Vesta, and you had
Yeah.
12 planets, and then they went back down to 8, and then
Yeah.
you got Pluto, and then you had 9, and then and the Eris is the same size as Pluto, maybe
Right.
bigger. Does that get to be a planet? What about Haumea, Makemake? It goes on and on
I
and
want
on. And
series back.
Ceres could come back. And
Yeah.
so you're never gonna get 9 planets. And if you want Pluto to be a planet, no problem. You just then also have to memorize Ceres, Eris,
Iris.
Haumea,
Yeah.
Makemake, Sedna. It goes on and on and
Yeah.
on. So then you're probably gonna have to memorize 20 objects and have them. You're
That's
gonna have to
okay.
my very excellent mother just
You need a
served
paragraph.
exactly. You're gonna need a giant paragraph to remember all of your planets. Is that what you want? Is that what you want for your children?
I
Like,
come from a nation with 50 states and 50 state capitals that we had to memorize.
right.
So,
So you can handle, you got 50 slots in your brain for
yeah.
information.
Yeah.
Okay. But yeah, so it doesn't matter. It's all just each one is its own special world. And
Yeah.
I 100% agree with you. Let's shift to world because then Enceladus gets to be a world. Titan gets to be
Titan.
a world. Yeah. Yeah, you're
It's
onto
an
something.
amazing set of geology out there. And I didn't know I liked rocks until we started sending space probes out to find salty, briny volcanism on Ceres. It's kind of awesome, and we need to acknowledge that small things have dynamics too.
So then what does the future hold for this? I mean, assuming when Vera Rubin comes
Yeah.
online. It's not assuming. There's no launch that needs
No.
to happen.
No.
It's
It
on a
will,
mountain. It's on a nice
and
stable
they can
mountain in Chile.
repair it
They
as
can repair it.
needed.
Yeah. Yeah. So we are just like, and it's not long, like a year. We're about a
Yeah.
year away from first light from Vera Rubin. So
Yeah.
when
Once
Vera
they can
Rubin
get
comes
everyone back
online,
on the mountain. So there's still the getting everyone back on the mountain.
right.
But yeah,
So
it's close.
so
It's
then it's going to find planet 9. It's going to maybe find planet 10. But is there like a lot of these things out there? Like, what do you think are the limits of what Vera Rubin could find?
my opinion on that keeps shifting as we keep realizing how many worlds in the known parts of the solar system have been clobbered. It's been realized that both Jupiter and Saturn have slightly fluffy cores thanks to measurements of their mass distribution by orbiting spacecraft.
Mhm.
And the way you get fluffy cores is you hit them really hard. We are pretty sure that Earth got its moon from a collision with a Mars-sized object, or possibly two collisions. Venus appears to have been inundated with a series of collisions to get it to its state of rotation and mass distribution. So if we had all of these collisions going on, it means there was a whole lot of stuff going on, and not all of these collisions had to lead to either the impactor being destroyed or the impactor being conglomerated into the surviving world. There are notions that maybe Venus experienced a series of glancing blows that just slowed that sucker's rotation
Mhm.
down. All of these collisions make me think there's room for 5, 10. We can't imagine exactly smaller, rockier worlds and possibly one or two Neptune-sized things out there. We know Neptune-sized objects are basically the primary planet found out there, and the dearth of them in our own solar system is something confusing. So maybe we'll find them. When we look at forming solar systems with ALMA, they're huge. We don't know how big our planets could be out in the edges where we can't see them yet.
Um, and so I wonder, could there be something Jupiter-sized out there? Could the solar system have captured an object from another star system, or maybe a rogue planet or something like that? Like it's hard to understand like how big the Oort cloud really is. Like it extends out almost
Yeah.
2 light years from the Earth. There could be a big object out in the Oort cloud that we would never know about and
And
never detect.
this is where missions like WISE are so important. One of the things I heard at a conference that just sort of like hit me as, okay, you have changed my worldview of our solar system,
Yeah.
is because it's so hard to tell the distance to brown dwarfs. We could have detected that our solar system is actually in a binary system with a brown dwarf, and we just couldn't measure the motions correctly.
No.
And if there's a Jupiter at a reasonable distance, it probably would have been found by WISE if it was in the areas of the sky that WISE observed. There's always the chance that something's in a crazy orbit, that because it's moving so slow, it was in a patch of the sky we've missed so far. But the universe likes to say, I will take your that's impossible and prove you wrong. And I'm no longer willing to say that's impossible.
Yeah.
I'm pretty sure it is a very low probability that we're actually in an unknown binary system. I think it's probably a very low probability that there is a Jupiter mass object out there that WISE didn't find. But Neptune and Mars-sized things, sure,
Yeah.
have at it. Those can be out
Yeah.
there hiding.
Yeah, so I just to put a pin in that, right? That idea of the WISE telescope, its job was to search for the kinds of cool brown dwarf large Jupiter objects in our nearby vicinity. I
Yeah,
mean, this that question was asked and answered
yeah,
by thanks to WISE. And so now we know there's probably not some brown dwarf giant rogue planet, but there could be a vast collection of objects that were too small, too cool for WISE
right.
and school. All right, we've reached the end of this week's episode. Thank you, Pamela. That was super fun, and I hope we do find many more objects.
Yeah.
More is better.
And hopefully while we're recording.
Sure, yeah. Now, do you have any names for us this week?
I do. As always, I have to say thank you to all the people out there that make this show possible, thanks to their sustained support through Patreon. Patreon really is the best way that you can help us out. And if you make an annual donation, paying for the entire year during this month of October, it will count towards our Hangout-a-thon goal. All right, so this week I want to thank Omar Del Riviero, Cooper, Alex Rain, Kenneth Ryan, Dean McDaniel, Jeremy Kerwin, Don Mundus, Eran Segev, Stephen Shewalter, Karthik Venkatraman, Daniel Loosely, Shannon Humber, Froda Tenenbaum, Janelle Duncan, Bogman McBlustersmoke, J. Alex Anderson, Mark H. Windick, Merrick Vidarni, Jim McGeehan, John, Matt Rucker, Michelle Cullen, Abraham Cottrell, Antisaur, Philip Grand, Mark Stephen Raznak, and Father Prax. Thank you all so much for being part of what allows us to put this show out.
Thanks, everyone, and we'll see you next week.
Bye-bye.
Okay, then they saved.
Yep, I'm going to trust Allie. Yes.
6:15. Okay.
Stella is, she tried so hard to hop up while we were recording and then fell asleep on the ottoman, and she's very cute.
So we got a couple of minutes. So first, Cat's Game was asking over and over and over again for us to talk about Planet Tyche, and we did at the end there. So I hope that gave you the answer that you were looking for.
Tyche?
Which was Tyche. So Tyche was a theoretical planet that was proposed back in the late 90s by a bunch of astronomers, that there could be an object with multiple times the mass and size of Jupiter way out in the distant solar system. And as you said, the WISE telescope, NASA's WISE instrument, was launched, and it was able to rule out, because it's exactly the right machine to find those kinds of objects. It was able to rule out a Jupiter-sized world out to 26,000 astronomical units, so half a light year, and it was able to rule out a Saturn-sized object out to 10,000 astronomical units. So thanks to WISE, we know that there are no giant objects in the outer solar system all the way out to essentially the entire Oort cloud. Those have been ruled out, and that's about 6 years old. So there's your answer, Cat's Game. All right, let's do some other questions. Arjun, wouldn't we notice weirdness in the sun's revolution around the Milky Way if we had a stellar companion?
Say that again?
Wouldn't we notice weirdness in the sun's revolution around the Milky Way if we had a stellar companion?
I don't think we have a long enough baseline.
Like, would we see a wobble? I guess I'm imagining like if the sun was being yanked back and forth by some other object's gravity, would we see the Milky Way, like literally just the background of the universe, shift back and forth by some amount?
I think if we had an Uber version of Gaia collecting data for hundreds of years, maybe.
Yeah.
But we don't have that kind of a baseline or accuracy. So we'd only be able to see it relative to basically doing extremely precise astrometric measurements of quasars and seeing how those shift.
Right. So there would be like this long duration shift of everything in space.
Yeah.
Slowly drifting in one direction, and then maybe everything in space slowly drifting in another direction. And it would have to be built up over time. And you're like, hey, everything in the universe is shifting to the right at some weird speed.
Well, and we'd need a large enough baseline that we could see our motion, the motion of the nearest stars, because you need to have the quasars to basically set the 0 point. You need to have the nearby stars that allow you to see how you're moving through the galaxy.
Yeah.
And it's basically wheels within wheels, and the motions are so slight and so slow. We orbit over 250 million years. That, yeah, I
Yeah. So, I mean, let's say it took
over the course of
10,000
the
years
yeah,
for the sun and its companion to orbit one another.
right.
You would have to be able to measure
We orbit over
a 10,000 year
yeah.
drift. So no. Quad Limit asks, I like to think about our distant future and practical use of things. Last week I learned that Pluto could be used as a source of water. What use could future humans find for Planet 9?
Um so there was a paper earlier this week that looked at Planet Nine. You're running my audio, Allie. You pressed play on my audio. Okay, sorry. I suddenly heard myself, and it was
Yeah.
very disconcerting. Um, there's a cat playing
I can't
audio.
believe the amount of animal mayhem that goes into the creation of our episode. Should I let Ona come over and just participate
Yes,
in this
yes.
engineering? Yeah. Yeah. Ona, come on. Let's go. It's time. We're making an episode of Astronomy Cast. We need that dog participation, especially a deaf dog.
So what I was saying is there was a paper I read the other day proposing um, using the sun to do gravitational lens based observing to be able to make out features on extrasolar planets orbiting clearly extrasolar stars, so not the
Mhm.
sun. Um, and I can imagine Planet Nine being a good relay point on the way out to wherever
Hmm.
you'd have to put that kind of a system.
Yeah, because you need to be like 550 astronomical units
Yeah,
out. Better is like 1,000 because at 550 the sun glares too bright. But if
yeah,
you get out to 1,000 AU, you can put a star shade up and just block the light from the sun, and then but still use the gravity of the sun
yeah,
as a lens. So having a world out there at say 10,000, and maybe it's got a moon around it, and the moon has tidal heating, and so the moon is reasonably warm. I love it. That's a great
yeah,
idea.
yeah.
That's awesome.
Or at least, I mean, Planet Nine's probably closer to 2 to 300 AU, so a way station on your way out there.
A place to refuel your fusion drive.
Or to boost the radio signals. You can imagine sticking a detector, a receiver there that grabs signal from the poor distant spacecraft, amplifies the signal, and beams it in
Right.
towards Earth.
Dustin King asks, how likely are alternative explanations like the Kuiper Belt objects shepherding each other instead of a planet doing it? That's a really interesting question.
So there are alternative theories.
Yeah.
One is that our solar system was essentially swiped by an outside star. Uh, that there are some interesting resonance effects that could lead to what we're seeing, and also just observational bias could be at play where there's actually a completely random distribution of Kuiper Belt objects, and our not yet full sky surveys just haven't detected all of them. And so what we have is just bias based on where we've been able to look so far.
Um, John Seville asks, somewhat off topic, but what is the orbital period of the Oort cloud? That's a great question. I've never heard that question before.
Yeah, it's tens of thousands of years.
It's
Um,
Is it
I,
millions of years? Like
so
how long does it take a long period comet to come into the inner solar system?
okay, hold on. Yeah, I don't know. I'd have to Google. I'm
Yeah.
sorry.
let me see how long it takes them. So long period comets have orbits that are longer than 200 years. I'm
Yeah.
seeing, yeah, I'm seeing them all in the hundreds of years. So that doesn't work. So I mean, we know, say, Pluto takes what? Oh man, what's the orbital period of Pluto? Like
It's like
300 years?
239.
Yeah. So it would be, we would be in the thousands of years to tens of thousands of years, I guess.
Yeah, yeah.
Yeah.
It's I want to say it's tens of thousands for the inner part of the Oort cloud.
Yeah.
248. Pluto's orbit is
There you
248.
go. Yeah. That's interesting. It's a great question. I've
Yeah.
never seen that asked before. Huh. I mean, you could do the math. I mean, I guess
Yeah.
like you could calculate
P
the,
squared
yeah,
equals a cubed. So
calculate the orbital period of
yeah,
an
let me
object
pull
at
up
a
a
certain distance.
calculator that has cubes on it.
So use, say, 50,000 astronomical units.
Yeah, hold on. Still need to find something that allows me to do cube roots.
And now I'm going to see if I can find an orbital period calculator. I'll race you.
So
Um,
A is 50,000, you said?
yeah, 50,000. Planet. So we know that. Semi-major act. Okay, so it's 50,000. I think I might have it's one solar mass.
It doesn't do a science.
I got I got it, 11 million
Okay.
years. So if
Yeah.
you're at 50,000 astronomical units, you're 11 million years, and that's about 2 light years away. So that's the farthest extent of the Oort cloud.
Yeah.
So
And
millions of years.
for the furthest extent, the inner edge is a whole lot closer.
Sure, say you're 10,000 AU, it's a million years.
So what's 1,000 AU?
1,000 AU,
So
31,000 years.
okay, that makes sense. Tens of thousands. Yeah.
Yeah. Look at that. Just mathed it. Just mathed it in real time for you. And that's the end of our episode.
It is. It is.
So thanks everybody for joining us this week. Pamela, obviously, I guess one last great shameless self promotion for the Hangout-a-thon. Well, actually,
Hangout-a-thon.
it's next weekend, right?
Yeah. So
Yeah.
it's 8 days away. um, so we're going to be doing 36 straight hours of streaming on twitch.tv/CosmoQuest X.
Wait, are we going to do I'm assuming we're going to do like one and maybe two episodes of Astronomy Cast during the
Yeah, we
Hangout-a-thon.
can
Yeah.
totally
Okay.
do that.
Yeah.
Um, and guests, Minecraft, all sorts of games and door prizes, and lots of ways to support us. The best way you can support us is on patreon.com. All annual, pay the whole year in advance, new memberships started this October count towards the Hangout-a-thon.
Fantastic.
So go give, become part of making us able to just keep doing what we do. So thank you.
Fantastic. Well, and I'm going to be releasing my latest question show probably in a couple of hours. My newsletter, I'm still writing my newsletter. But I've only got like 5 stories left to go. So probably an hour after Astronomy Cast finishes, my newsletter is going to go out the door. So if you want to be on my free weekly email newsletter, go to universetoday.com/newsletter and you can sign up. Hurry. You're running out of time. You've got an hour. And
Awesome.
then you're just going to have to, then what happened this week will forever be a mystery to you. But it will include pictures, my Aurora pictures from this week.
I
So
need to see those.
you got to
And
see it.
I get your newsletter, so I will see those.
Fantastic. Thank you for your support. All right. Thanks, everybody. Thank you to, of course, all of the moderators, everyone watching us both on YouTube and on Twitch.
Yeah.
Thanks to Allie for joining us in engineering behind the scenes, and Nancy for herding the cats and organizing us as well. We could not do this without all of you. So thanks, everybody. And we'll see you next week.